verilog, but everything will be the same.
ಯಾರು ಒಬ್ಬರು ವಿಡಿಯೋ ಮಾಡ್ರಿ ಸಾಕು.
Okay, I need. Shall I
Yes,
start?
ma'am. Yes, ma'am.
I need to click on this xilink. There will be a number of windows open. Just close this top view. Sorry, tip of the day. Expand this. Close this design summary also. I need to have a blank sheet like this.
Yes, ma'am.
Then go to file. In your exam, you should always start with a new project. New project. Give a random project name. I'll give computer science. Computer science. Some project name. Any project name you can give. You can give your own name also. I'll give a small name. Your name you can give. Please remember the top level source has to be HDL only because you are writing a HDL code. Next. This is regarding the device. The program will be downloaded onto a hardware device. These are the features of the device. Since you all are not downloading the program onto your device, anything here will not be a problem to your program. But this should be proper. Top level source has to be HDL. The synthesis tool should be xilink synthesis tool only. And simulator, I told you, morning also I was telling you, I don't know what you're using in your lab. We preferably use models in XC, VHDL or ISC simulator. But right now, since we are doing ISC, I will click on ISC. I think that only your CS people are also using. Okay? Just say next. This three you need to be worried about, not this. Just say next. Now you need to create a new file, your program, whatever program you need. So you will have this create new source. Just click on new source here. You need to give a program of your choice. The first program was multiplexer program, so I will give a name as MUX. Okay, any name you can give. Just say, sorry, please, I forgot to mention. Please select which code you are writing. Either you are writing VHDL or verilog. Since in your manual VHDL is given, I will click on VHDL module. Then you give the name as MUX. Clear? Then say next. Now this file will come. Do you have a manual? Okay, if you had your manual, anything, one multiplexer, 8 inputs, 3 select lines and 1 output. All of you know the working of a MUX? Yes? So 8-bit input, they've declared it as a vector. All of you know that, right? In-bit vector and all that I have declared in same way. They've declared it as a vector 7 down to 0. Select, they've declared it as a vector 3-bit 2 down to 0. And 1 output, they've declared it as Z out. Clear? So I will select I as one input. But is it a single bit input or a vector? Vector. It's a first input. So you click on this select input. Okay, it's a vector. Since it's a vector, select bus. Okay, how many bit vector is it? 7 down to 0. So please write 7 down to 0 here.
7 to 0.
Then next one is SEL, which is a select line. Select line. Again, it's again an input. So you're keeping it as an input, but again it's a vector.
2 down to
so
0.
Click 2 down to 0. Okay. Then you have a third input, third output Z out. So you have Z out, it's an output, so you click on this output. Is it a vector? No. So don't do anything, that's all. Just say next, finish, next. Whatever is coming, just go on saying next till you get the screen. The summary will keep coming, just close it. See here, this entire first part of your program is already written here. Can you see?
Yes, ma'am.
You don't have to worry about it at all. You need to type only between here, begin and end you need to type. That is this portion. This logic I will explain later, maybe next when you are coming. So I'll just type out what is this. This is a data flow way of writing a 8:1 MUX in VHDL. Okay, yes. There is something called as when else statement. When this condition, do this. When this condition, do that. That's in VHDL. We don't have that in verilog. So I'm going to copy the same thing. Z out is equal to I of 0 when select is equal to, remember we wrote select is equal to 2 high colon bit 0 0 0. Here it's in inverted quotes, you need to write like this. It's the same thing but little syntax move. I of 1 when select is equal to 0 0 1. Else I'll just copy this thing.
Select and copy.
I mean, I didn't want to type everything. Y'all can type it. I am making it easier for me, that's all. Y'all can type it out. 001. The code I'm just... Okay. Last one is I of 7. You are understanding this code, right?
Yes, ma'am.
It says when select line is 0 0 0, output was I0. When select line is 0 0 1, output is I1. When select line is 1 0 1, output is I5, like that. And after the last statement, there is a semicolon, but I am not putting that semicolon. I am purposely making a mistake and I am saving it. Okay. Please see here what you are having in this window. Please remember, it should always be sources for synthesis and implementation only. And your project, under that these are the features, under that this is a program, mux. And these 3 boxes have to be there. If it is not there, then you need to right click and say set as top module. Okay?
Stop module.
Sometimes all these options may not appear. If it doesn't appear, I'll tell you what to do, but right now it's appearing, so there's no problem. Click on synthesis, expand the synthesis. You have something called as check syntax. Okay, double click on check syntax. See, it's telling there's an error because I've forgotten semicolon. Either it will point to that line or to the next line, because it's saying the next line has started but you have not terminated the first line. So put the semicolon there. Once you have done it, save it again. And again you need to check syntax. Either you check syntax or do synthesis as a whole. It doesn't make any difference. Okay, synthesis is a longer process, but you need only check syntax, but you can do synthesis also directly. If synthesis is right, it means check syntax is right. You don't need to go and do check syntax. It's always right.
Yes.
Is it clear? But you all can do only check syntax. If this is done, your program is over now. What you need to do is you need to see the result. For that, you need to create a test bench waveform. How will you create a test bench waveform? Go to create new source. You're going to create a new test bench waveform. Double click. Now you're going to create a test bench waveform. So select test bench waveform. Okay, and give a random name. Mux you had given, so I'll give it as mux. Don't give it as mux, I'll give it as M1. Next, you're creating the test bench for which code? For mux only. Next, you'll get something like this. For a program without a clock, don't worry much about this. Just say finish, you'll get something like this. I is a 7 down to 0 vector, select is a 2 down to 0 vector. You expand these so that you can give inputs. Wherever this blue line is there, there you can change the inputs. See, I of 0 is 0 throughout. Wherever you want to make it 1, you can make it 1. Your choice. Just clicking. Just click. One of you can click here. You want to click wherever the blue line is, it will work.
Again, if you click that, it will come
Again, if
down.
you click
0.
here, it will become 0. That's all.
Fine.
Select line also. First I'm giving 0 0 0, then 0 0 1, then 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, something like this I have given. You all know, right? If it's 0 0 0, whatever is there in I0 should go to Z. If it is 0 0 1, whatever is there in I1 should go to Z. This is understood. Save it. Clear?
Yes.
Once you have saved, now you should change the sources from synthesis implementation to behavioral simulation. Then only you can run this program. Go to behavioral simulation. Now see, you get the test bench. When it was in synthesis and implementation, you get the code. Now you do behavioral simulation, you get your test bench. click on this test bench. You need to get some options here. If you are not getting those options, just click on this process. You will get these options. Expand the Xilink's ISE simulator, and there's something called a simulate behavioral model. Just double click on it. Over. That's all your program. Over. Now you got the answer. Again you can expand it and see. Select line is 0, 0, 0. What is I naught at this point?
0.
0. So my output is 0. See, select line is again 0, 0, 0. What is I naught at this point? 1. What is Z out at this point? 1. Understood. Like that you need to check. Oh. Now you need to do another program. Please close this first. Again go to synthesis and implementation, because you are going to do a new program. You need to get options here. You are not getting. Click on processes. Whenever you don't get any options here, click on process. You need to do a new program. So again go to create new source. Which program you need to do? VHDL module. So click on VHDL module. The next program is D flip-flop. So I will type it as D flip-flop. Next. According to yours, there is D input, clock, Q is an output. This is how they have defined it. And they have defined Q bar is also an output. This is how they have defined in your this one. Next. We got the code as it is. Clear? And according to your program, they have initialized here equal to 1. Not necessary, but they have done it. Not necessary actually. Is it clear? If you want, you can initialize this to 0 to be more appropriate then. This is 0, this is 1. Q is 0, Q bar is 1. Now see, begin. The code is like this. You have a clock, so you should always have a always statement. Instead of always, there's something called as process. This is process clock. Begin. This is the syntax. So I'm not doing anything. I'm just writing the syntax. If you want, I will teach you all this. Okay? Always at positive edge of clock. Instead of that, if rising edge of clock is there. That's all. Okay? Then Q is equal to D. Q bar is equal to naught of D. See, naught we put a symbol, remember, in verilog.
Yes, ma'am.
This kind of a symbol we put, but here we have a not, and like that you need to write. Because you have started with if statement, there is an end if, and because you have started a begin here, there is an end process. This is a syntax. I will teach the syntax on Friday. I have told the class. Is it clear? Understood? Again you do the save. Now you see, where is the symbol? It should be a D flip-flop. Where is it? At mux. So you click on D flip-flop, right click and set it as stop module. Okay. And then do synthesis or check syntax. Process failed. Why? Okay, I have a lot of mistakes. If rising edge of clock, what was the mistake? I should put this in brackets. Oh, that was your only mistake, so it's done. That's all. Over. Your program is done. Now again go to create new source. Test bench waveform. You're creating a test bench waveform for D flip-flop. So I write it as DFF1. A different name I'm giving. Next. Is it for D flip-flop or for mux you're creating? D flip-flop. So it should be selected. Next. Finish. See, now this one is highlighted. Please remember, it should be selected at single clock, not at multiple clock. Okay, and it's saying clock high time and clock is remaining high for 100 nanoseconds. It's remaining low for 100 nanoseconds. If you want to change here, you change here. Otherwise, don't change. And I told you, your entire devices can work with rising edge or with falling edge. But this program has chosen rising edge. If you want falling edge, you can click on that. But that's not needed. Just say finish. You've got it. You can change D. D is 1, D is 0, D is 1, D is 0. Randomly, I have changed. Whatever is there on D, the same thing should come to Q. Understood? Can you see here? Is where are they given us option to change D? At the clock or before the clock?
Before the clock.
I remember I was telling you the D input has to become active before the clock should come. Now save it. Now where you need to go? Should it be at synthesis or behavioral simulation? Behaviorals. And please select D flip-flop 1, not M1. D flip-flop 1, select process, simulate behavioral model. Over. That's all is it. See, whenever clock is there, whatever is there on D, it comes on Q also. Over. Is it clear? The same thing, if you all are not understanding VHDL module, I want to do verilog module means there is no change at all. I'm just telling you in case. You did file new project name you gave something, all this you chose, new source you selected. What did you select here? VHDL module. No, you select verilog module. That's all. You can give the same name, D flip flop, D clock, Q as output. I'm simply showing you. See, you have got the VHDL, verilog. This is how we write, no? Verilog. That's it. Have you all understood?